Okay, good morning everyone. We are going to go through the prelim practice that we have done on the practical. So for this video, you should get back the question paper and also a piece of marking scheme. So on the question paper, I have already marked for you the design experiment. What you need to do is that I want you to watch this video, and as you are watching, I want you to mark on your own marking scheme. At the end of the video, you need to do your correction, and together with your marking scheme, please staple it at the front of your question paper. You need to submit it to me. Then I will confirm that your marking is correct. Now, I'm very sorry that I couldn't use lesson time to do this because we are actually behind time at the moment. So you need to watch this video on your own. So I have used one of your classmates' submission, the lab report submission, as the sample for us to mark. So this is the question paper, and you should also get your marking scheme, which is in the form of this. Okay, so what we are going to do is that we are going to look at each of these components and then we will mark together. Yeah, so please get ready these two documents. Okay, just a quick recap. So this is for your, is in the prelim format, meaning that you will have your section A, section B. So in the first experiment, what you did is that you have this metal wire that you need to use the, what do you call that, this mesh slot to hook onto the wire, and then after that you are supposed to rotate this 2 times, and then after that you let it go. So when you let it go, this thing is going to spin backwards, and then after 2 complete oscillation, you are supposed to take the time. Okay, so this is a quick recap on what you have done. So let's take a look. So first you need to measure the length of the wire. So for the length of the wire, they have actually told you to adjust the distance so that it is about 30 cm. So when you see this, what is the meaning of 30 cm? It means that it is acceptable to get 29.5 cm to 30.4 cm. Okay, so we accept this range. So if you look at this student, I don't know why, but she just assigned her own length, so she will be marked down on the accuracy, but her precision over here is correct. The unit is also correct. So how would we give the mark? So we take a look. So L has to be recorded to 1 dp and is in cm, and we will deduct mark for out of range in 1b. So for here, we will not penalize her for not reading the range over here, but I will just point to it. So down here, she will get no penalization on the accuracy. Then after that, you are supposed to measure and record the total mass of M held by the wire. So for this, you are not required to actually use the electronic balance to measure the mass. You can just look at your metal mass. So if you take a closer look at your metal mass, you will see that your metal mass, right, has this marking on it that says 50 gram. So looking at the marking, you will see that the precision is actually 0 dp. So very good. It is 0 dp, the unit is correct, the calculation I think is also correct. So let's take a look at the marking scheme. So like I said, 0 dp in gram, 400 grams. So she will get the full 1 mark here. So down here you will record down your mark, and then down here you can make a marking for easy reference. Okay, this is the part whereby later on in your design experiment, you can just refer to this. This is what we call the step that asks you to spin. So instead of copying all these things in your design experiment, you can just refer to it as step B in page 2. Okay, so down here, what happened is that at the back end, if you know about oscillation, this particular time is actually affected by your L. So for this student, when she didn't follow the L given over here, we are not penalizing the accuracy here, but we will penalize her accuracy for T. So her T is 4.84, precision wise correct, unit wise correct. So then let's take a look at the marking scheme. So T is measured by 2 dp in seconds, And now if we look at the range 6.5 to 7.5, and you will notice that she is out of range. Right, so this one we will just say out of range, and she will get penalized for that. So let's see what is the penalty. So down here, this one, she didn't make it. So for practical, there is no half mark, strictly speaking. So actually down here, depending on the cohort, how they are performing, we will give it a mark. So, but since this is a practice, I will give her maybe 0.5. Okay, the next thing, let's carry on and mark this. After that, you are supposed to do an operation to find T, which is for one period for one oscillation. So the T that you have found is for 2 oscillations. So therefore, you need to get your capital T first. So how she get this? It will be better for you to write down how you get it. So this is your 4.84. Remember, you need to write the full precision here, divided by 2. So this 2 is an exact number. So by dividing by an exact number, you will follow the least dp rule. So therefore, she is following the least dp rule. Then after that, when she do the t square is falling under the other operation domain. So for your t square, you will have to follow the least SF rule. So what is t square? Your t square is actually equals to 2.42 whole thing square. So the least SF is actually 1SF, 2SF, 3SF. So for your final answer, you should give me 5.86. This one is 3SF. Okay, and the unit will be second square. So for Devon, very good. I will give her the benefit of the doubt. This is wrong, but this is correct. So 5.86 correct, unit correct. Okay, and since I have already penalized her on the accuracy, I will not penalize her on that again. So I think she will get the full mark. So let's see. Down here, 3SF, unit S square, correct calculation. So 1 point. So down here, she is getting 1. Here is getting 0.5. Okay, after that, you are given the formula for this to describe this experiment. So they are saying that use your result in A to determine a value for K, and she did a good job. She did a full substitution with the precision written. So let's check. Capital T, 2.42, correct. The mass, 400 with 0 dp, correct. 2 pi. Okay, so down here, it is, of course, follow least SF rule. So down here, you need to follow the least SF rule of your reading. So what are readings? Readings are things that is not exact. So this is a reading, this is a reading. Your K and your 2 pi is an exact number. So down here, very good. The least SF will be your 3SF. Okay, and she found the full value, and then she round it up to 3SF. And then she also work out the unit. So the unit, how to work out? How to work out the unit? Okay, 2.42 is, so let's write this down. K, okay, down here she work out. 400 is the mass. So this guy is in gram. Down here below, it is 2 pi has no unit, but 2.42 is the time, right? So it will be second square because of the square over here. So very good, G over second square. Excellent. I shouldn't say the student name, but excellent. Okay, good job. So down here, correct calculation, 3SF, correct unit. Okay. So let's carry on. Very good presentation. Independent variable is in mass. The unit is G. Time taken for 2 oscillation. Very good. Correct symbol, correct unit. Length of wire, good. Material of mass, not so much. But what we are looking out is actually the shape. Because different shape will affect the air resistance acting on it, and it will affect your period of oscillation. The height of mass from the ground, not so much, but the material for the wire, yes. Okay. So set up the experiment according to 1.1, okay. You set the L as 20, fine. Record the mass as M. For this particular experiment, because you are reading it directly on the mass, you don't need to say using an electronic balance. But as a good practice, you can still say that it is using an electronic balance. It's fine, it's okay. Or you can say that you are reading it directly from the mass, it's okay. And for this student, she forget the step to spin the thing. So before you spin the thing, how can you measure the period, right? So missing spin step. Okay. Measure record time taken for 2 oscillations. So it's very good because sometimes some students want to take shortcut and want to measure 1 oscillation and they will be penalized because when you measure 1 oscillation, the percentage of random error will be high. So very good. She also say that the symbol is T using the correct equipment. Then after that, with the same M, repeat the correct step but record it as T2. And she want to calculate average T using this formula. So very good, equals. And you notice that there's a T1 over here. So that means down here, she also need to change this to T1. Okay. So, and she remember that the capital T is actually, you need to divide the small t by 2. T square, very good. Reading of M, this one better to call it T1. T2, average T, capital T, T square, excellent. By varying the mass, okay, repeat step, the correct number of T is fine. And she want to plot a graph. Oh, unfortunately down here, she's not very sure how to play with this. So let me take this opportunity to do this. So in your submission for your exam, this is just your working. You don't you can do it on your question paper, so you don't need to really show it. So what you need to first identify is that you need to group the exact number or the constant term together. So I will break this down into this. Correct, right? And I can see that this and this are the constant terms. So I will continue to break it down. I'm just changing this. Can see? So now this entire thing is a constant term. So what does this look like? Y equals to mx plus c. So this will be your y-axis. This will be your x-axis. So therefore, she should plot down here t versus square root m. Okay? And how to find the k? So down here, you will see that this part corresponds to the gradient. So from here, you can see that your gradient is equals to 2 pi over square root k, meaning that your square root k is 2 pi over gradient. So therefore, your k is 4 pi square over gradient square. Okay? So unfortunately, this part, she got it wrong. So with a design like that, how would I grade it? So let's go to your grading paper. Correct decoration, right? Correct T. Unfortunately, the statement for the instruction for the averaging, she forget to change T to T1, so I will penalize her half. Unfortunately, wrong graph. She did set the first dummy value. She remember this. She make an excellent statement, repeat the step and all that. So I think overall, I will just minus half for her. But unfortunately, she's unable to give me the correct expression for K. So it's minus 1. So in total, she will get 3 out of 5. So this one, she will get 3 out of 5.